All right, number 3. These are composites, so this P of Q of 4 is the same as saying P, or P composite Q of 4 is really P of Q of 4. And what that means is we need to plug Q of 4 into P, so we should probably find Q of 4 first. So Q of 4 is the opposite of 2 times parentheses minus 12, and so that's going to be in the parentheses, we want to put a 4. So then this is the opposite of the absolute value of 8 minus 12, which is the opposite of negative 4. Well, the absolute value of negative 4 is 4 units. So Q of 4 is going to be the opposite of 4. So the absolute value of negative 4 is 4, so our answer is negative 4. And what that means now is we want to take this Q of 4 value and plug it into P. So instead of putting Q of 4, we actually put the value negative 4. So then we get 3 parentheses to the 4th minus parentheses squared, and then we plug in negative 4, and then you go to your calculator and we need to type that in. Let's see what we got here. So negative 4, negative 4, so you can type it in exactly as is here. Oops. There we go. And then you get 752. So that equals 752. Okay, now on the next one here, we're starting with Q. So now I want Q of P of negative 1, which means I need to evaluate P of negative 1 first. So that's 3 parentheses to the 4th minus parentheses squared. I'm plugging in negative 1. Negative 1 to the 4th is positive 1. So this is really just 3 times 1, minus negative 1 squared is positive 1. So this is really 3 minus 1, and that's just going to be 2. So now I want to find Q of P of negative 1, which is 2. So I plug in 2 here, and this is the opposite of the absolute value of 2 parentheses minus 12. In the parentheses, I'm plugging in a 2. So this is the opposite of 4 minus 12, which is the opposite of the absolute value of negative 8. Negative 8 is 8 units from 0, so this is the opposite of 8. Okay, we got to work our inside out. So f of 1, we take a look. F is the solid graph. We look at when x is 1, and when x is 1, this point is 1, negative 1. So this equals negative 1. So that means that I want to find g of negative 1. So I come over to g. Here's negative 1. G is the dotted graph, and this point is 1, 3. So, sorry, negative 1, 3. So g of negative 1 is positive 3. All right, for the next part, this is f of g of negative 1. But we know g of negative 1. Oops, I like how I deleted this. G of negative 1 is positive 3. So I'm really finding f of 3. So I come over here, 3, follow this down. I have the point 3, negative 3. So the answer here is negative 3. And then the last one, this is a little bit of a doozy here. For the last one, we're going to have, let's find f of negative 4 first. So f of negative 4, f is the solid one, so that's up here. So negative 4, 5. Okay, now I need to come over here to this g. So I'm finding g of 5. So I come over to 5, and that's 2, so that's a 0.52. And then I want to find f of 2. So I come over to 2, 1, 2, 3, 4, so that is 4. And then for the tables, it's going to work the same way as it does in the graph. So I want to find a of negative 3 first. So a of negative 3 means x is negative 3. And I'm using this graph because this is a here. Okay, so that's going to be 0. But then, so this is a. But then, this table is b. And I want to find b of a of 3. So I want to find b of 0. So when I come over here, find 0, and that's going to be negative 1. Okay? And this is b of a of negative 4. So I need to find a of negative 4 first. So that's going to be b of a of negative 4. I come over here, negative 4. That's 1. And then b of 1 is negative 2. And then for the last one, it's b of a of b of 0. Okay, so b of 0, come over to b, find 0, that's negative 1. So this is really a of negative 1. And a of negative 1, and don't forget this b here. So a, negative 1, is negative 2. So I'm really finding b of negative 2, and b of negative 2 is positive 1.